All right. I like being able to erase the board in between examples. It's kind of nice. Okay, some other things we can do with double angle identities. As usual, we can verify other identities using these double angle identities. Let me give you a couple examples of that. So let's do cotangent x sine 2x equals 1 plus cosine 2x. I'll be honest, I have no idea how this is gonna go. I haven't worked this out beforehand. I'll tell you what though, one of the things that I'm inclined to do right away, like this cotangent to me just kind of sticks out like a sore thumb. It's like if I already have sines and cosines in the problem, then to me it's just easier to rewrite everything in terms of sines and cosines. So I'll start there, and I know that cotangent is cosine over sine. I'm going to rewrite this as cosine x over sine x. The next thing I'm going to do is I notice that I have these double angles. So I'm going to use a double angle identity to rewrite this as just a function of x alone instead of 2x. Because then I think I might get some cancellations or something. So sine 2x, I'm thinking the double angle identity for that is 2 sine x cosine x. And sure enough, right, so I've got the sine x's are going to cancel now. So I'm just going to get, this is just going to be 2 times cosine squared x. Okay, does that make sense? See, there I go, asking if it makes sense. You can't answer that question. Anyway, 2 times cosine squared x. I'm trying to get it to look like this. And I can kind of see a relationship. I know that one of the identities for cosine 2x involves a cosine squared x. In fact, I think it's 2 cosine squared x minus 1, right? So maybe one thing that I could do is I could stop working on the left-hand side and maybe start working on the right-hand side and try to manipulate this so that it looks like that by applying a double angle identity here. The other thing I could do is do kind of a fancy little algebraic manipulation. I could say, like, if I add 1, that's fine as long as I subtract it off here. And there it is, right? Because you agree with that what I have now, what I have written now, is exactly equivalent to what's written just in the blue, right? Adding 1 and then subtracting 1 doesn't change the quantity. But what this does now is that if I'm thinking about 1 plus 2 cosine squared x, that is my identity for cosine 2, or sorry. Nope. It's this one, right? Yep, it's this one. 2 cosine squared x minus 1, that's my identity for cosine 2x, right? So now I can say, so this is 1 plus cosine 2x, and sure enough, right, that's where I wanted to end up. I think that's probably the quickest and easiest way to get there. If you didn't see that little trick, right, like if you didn't think about doing that little trick, that's okay. When you got to this point, you could have just said, all right, so I'm going to stop working on the left-hand side. I'm going to start working on the right-hand side. I can rewrite this as 1 plus, what did we say a second ago? 2 cosine squared x minus 1. The 1 and the negative 1 cancel. And sure enough, right, you end up back at this place. So, Okay, so that's that one. Let's look at another one. Again, pause the videos, try to work them out yourself. See if you can work them out yourself before you look at the solution. You might come up with a solution that's better than mine. Here's another one that I have not looked at. So cross your fingers. Let's see how this goes. So we've got cosine 2x minus sine 2x squared equals 1 minus sine 4x. Okay, pause the video, give it a try. I'm going to work it out. So, okay, when I see this, two things occur to me right off the bat. One of the things that occurs to me is that I'm using different multiples of the angle x in these locations, right? So I've got 2x here, but I've got 4x there. And the good news is that I can rewrite this one in terms of 2x, right? I know that sine 4x, I can think of this like sine of 2 times 2x, right? So I can think of it kind of like that. So this should just be sine 2x cosine 2x, right? So I know sine 4x should be the same as sine 2x cosine 2x. Just applying a double angle identity there. That might come in handy at some point. The other thing that that occurs to me is that I've got this binomial essentially that is being squared, and I kind of feel like expanding that binomial is going to reveal some useful things potentially. I just think generally if you have something like that that's being squared, probably best to just go ahead and square it and see what you've got at the end of the day. So let's do it. So I'm going to square this thing. Remember, you can't distribute the 2 across subtraction, right? So if you were thinking, oh, well, that's just cosine squared 2x minus sine squared 2x, you were wrong. I was going to say, you deserve to fail the class. Actually, you deserve to have failed Math 35 last semester if you thought that. But no, we're going to write this out twice in FOIL, right? We're going to say cosine 2x minus sine 2x times cosine 2x minus sine 2x, and FOIL this bad boy. So I'm going to get cosine squared 2x. I'm going to get a negative cosine 2x sine 2x. I'm going to get another one of those. And then a positive sine squared 2x. Oh, well that's, okay. So check it out, right? So we've got a cosine squared plus a sine squared. That's going to make 1, right? That's going to make 1. So really we just have 1. And then these two things are going to combine to give us negative 2 cosine 2x sine 2x. Okay? Oh, see, and now that's, okay, and there it is, right? We're done. We're done, right? Because that's where the other thing that kind of stood out to me from the beginning comes into play. Because if you recognize sine 4x is really 2 times sine 2x times cosine 2x, you know, then you recognize that this thing is just sine 4x in disguise, right? It's just sine 4x in disguise. So we really are done, right? So we say, oh, this is 1 minus sine 4x. That's it. So again, I'll write that out again just because I know I erased it and some of you are probably like, wait, how? But how do we get from here to here? Okay, so again, right? So notice that sine 4x, you can think of it like a double angle, even though it's really a quadruple angle, but you can think of it as the double angle, right? So you can think of it like this is sine of 2 times 2x. So the angle that you're doubling is 2x, right? Okay, well, what is the double angle formula? The double angle formula for sine is 2 sine of the angle cosine of the angle, right? So that sine 4x is 2 sine 2x cosine 2x. So then this stuff, right, matches there. The sine and cosine were written backwards, but it's the same quantity, right? So so this thing can be replaced with sine 4x, and there it is. Okay, so there's that one. I think I'm gonna start a new video.